biggest thing with whenever we graph logs, okay, it is just like a exponential, it's just the inverse of it. So when we have an exponential, we found an intercept, we found an asymptote, we had the domain and the range. So here we're still finding an intercept, we're still finding an asymptote, we're still finding the domain and range. The only difference is whenever we found an exponential, we found the y-intercept and our asymptote was k, or it was y equals. Whereas here, whenever we find an intercept, it's going to be an x-intercept. Your asymptote is going to be x equals, and then you're still finding the domain, and you're still finding the range. Now, with an exponential, like I put on the notes on Friday, with your domain and range, your domain was automatically negative infinity to positive infinity whenever we did exponential. Whereas with a log, it's going to be for your range. So, negative infinity to positive infinity. Okay, every single time. So it will always be negative infinity to positive infinity for the range of a logarithm, whereas, so that's with a log. When it was exponential, your domain was always negative infinity to positive infinity. So in the order in which I would solve this, I would always do the range first, I would do your asymptote second, I would do your x-intercept third, and then I would worry about the domain. We're going to do this very similar to how we did exponentials. Okay. Now, with exponentials, your asymptote was always your k value, okay, whatever was plus or minus on the backside. Whereas for your asymptote of a logarithm, you need to look at your h value. Okay, you're going to look at your h value. So in this case, if, like I gave you on the first part of the notes, if we have a times log base b of x minus h plus k, basically what you're going to do to find your asymptote is you're going to set that, whatever's inside that parenthesis, equal to 0. And that's going to be your restriction. Okay. More often than not, it's going to be x plus a number, x minus a number. Okay. There may be times whenever we get into talking about the domain in a minute that you will have, you may have an x squared or something like that. That's not normal. It's just kind of talking, we're just going to show you kind of what your options are as far as what x can and cannot be. So whenever we look at h, so if I'm looking at h, what value inside here can x not be? For it to not, it can't be 0 in there. So what can x not be? Positive 2. Okay. So if my asymptote's at 2, all I'm going to do is that I'm going to draw my imaginary line or my dashed line. Here. So there's my asymptote. Now, the next thing is your x-intercept. Your x-intercept is not necessarily that difficult, but it is a little bit more time-consuming than it was to be the y-intercept. Okay? You're not guaranteed to have a y-intercept here. Okay, because you're on either the left side of your asymptote or the right side. You may never be, if we're on the right side of my asymptote, I'm never even going to come close to my y-intercept, okay, or my y-axis. So in this case, if I have an x-intercept, before whenever I was trying to find the y-intercept, I plugged 0 in for x. So what do you think I'm going to plug 0 in for the x-intercept? Y. Okay. So if f of x is equal to log base 3 of x minus 2 plus 4, what's y? What realistically is y of my function? The f of x. So I'm going to go 0 equals log base 3 of x minus 2 plus 4. Now, I need to get the log by itself. So what do I need to move over to the left side? The 4. So if it's a positive 4 on the left, it's going to be a negative 4 on the right, and I'm going to have log base 3 of x minus 2. Once I get it to where it is just log base of something, then I'm going to turn this into an exponent. Okay, with any sort of log, the only way I can really solve any of these is turning it into an exponent. So from what we did Friday, I need to turn the log. What's my base of my log? 3. So I'm going to leave the 3 on the left side, or on the right side, excuse me. I'm going to have 3 here. I'm going to send the negative 4 over to the right. I'm going to send the x minus 2 over to the left. So I have 3 to the negative 4th power. So if it's 3 to the negative 4th, what's that going to do to my base? What's it going to do to my number on the right side? What does a negative do to anything? It makes it a fraction, it flips it over, right? So I'm just going to rewrite. I'm going to rewrite the x minus 2. And I'm going to have 1 over 3 to the 4th. Well, what is 3 to the 4th? What is 3 times itself 4 times? 81. So I have x minus 2 equals 1 over 81. Now, in this case, since this one, I wouldn't write it as a decimal. I would just leave it probably as a mixed number. You can write it as an improper fraction. It's really up to you. But the one thing I wouldn't do here is write it as a decimal. So I still need to get x by itself. So how am I going to get rid of the minus 2? I'm going to add 2. So I'm going to have x equals 2 and 1/81st. Or you could write it as 163 over 81. That's the same thing. Any of these would work. I would just stay away from the decimal because then you don't have to worry about how you're going to round it and all that stuff. Okay. So as far as my x-intercept is concerned, I'm okay with you writing it as 2 to the 1/81st, or if you want to write it as an improper fraction and go 1/63 over 81. Completely up to you. Now, in knowing that, I need to put a point on the x-axis of where I think 2 and 1/81st is, or 63 over 81, or whatever. 2 point, it's like 2.0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. So, about where is that? Just right past the, okay? It's basically right here. Okay, it's as close to touching this thing as possible. Okay? And that's probably really too far away already. So from there, is it on the left side of my asymptote or the right side of my asymptote? The right side. So can it cross over that line? No, not since I have an asymptote. So since it can't cross over, is it going to go to positive infinity or negative infinity? Positive infinity. So all I'm going to do is I'm going to take this number right here, and I'm going to go from 2 to positive infinity. Now, is the graph a big deal? Not so much, okay? Now, in this case, since it's going to come from the bottom up because it's positive, so it's going to keep going in a positive direction. So it's basically going to look something where whenever I draw it, I'm just going to take it and I'm just going to kind of wrap it around here. Okay, it's probably a little bit higher, but you get the idea. I'm still going to find the x-intercept. I'm still going to find the asymptote. I'm still going to find the domain. And I'm automatically going to put the range down as negative infinity to positive infinity. Now, this one's kind of a little bit tricky to a certain extent because what's my h? Or what do I need to set x equal? If I'm going to, is it x minus 1 equal to 0 or is it just x equal to 0? Just x. Why just x? Because there's no parenthesis. Okay? So if you don't have a parenthesis, okay, and it can get kind of tricky because it's like, okay, what does the 1 or the negative 1, minus 1 belong to? If there's no parenthesis, then really this just looks like that. Okay? Your negative 1 is your k. Okay? That's your k value, not your h. Now, with that also, what's that negative going to do to it when it's all said and done? Normally it goes from the bottom and it runs to the top, right? Where's it going to come from now? Top, and it's going to run to the bottom. Okay? So that negative, you just have to realize that it's going to flip everything upside down. That'll come here in a second whenever we graph. So first things first, we got our range. Our asymptote, we already talked about, is just x equal to 0. So I'm going to have my line here at 0. My dashed line at 0. Solve for my x-intercept. So whenever I solve for my x-intercept, I'm going to have 0 equals negative 2 log base 4 of x and then minus 1. So what do I need to move over first? I remember, I want to get log base 4 of x by itself. So what do I need to do first? Add 1. So I have 1 equals negative 2 log base 4 of x. Now what? Divide by negative 2. So I have negative 1/2 equals log base 4 of x. So now I have the log by itself. So I'm going to leave the 4 by itself. 1/2's going to the right side. The x is going to the left. So I'm going to have x equals 4 to the negative 1/2 power. So again, what's that negative going to do to my base? Where's it going to send it? Send it to the bottom. So I have 1 over 4 to the 1/2 power. What is the 1/2 power? What? Square root. So I have x over 1 over the square root of 4. What's the square root of 4? 2. So where's my x-intercept? 1/2. So then, put a little point there at 1/2. So again, what side of my, and I had a good question first hour about this. I had a student say, well, normally whenever you take the square root of a number, it's plus or minus. Okay, you're right. Okay, or he was right. Now, in this case, though, since there's no, the only time there's really going to be something on the left side is if you have the x negative inside the parenthesis, or if you have something to like a square, like if it's x squared. Okay, 95% of the time, if not more, your log function is going to be on the right side of your asymptote. Okay, there are times that it's going to be on both sides, and we'll get to that in a second. But normally, like in this case, it's going to be on the right side. So for my domain, I'm just going to go from 0 to positive infinity, because it's on the right side. Then from what we talked about earlier, since it's negative, instead of coming from the bottom up, it's going to come from the top down. Okay, don't forget that negative out in front. But it's going to flip everything over there. So with the domain, basically it's all x where whatever is on that backside is greater than 0. Okay, so it can't be negative. Okay, so if it can't be negative, if you need to basically set it up, whatever's inside this parenthesis here, x plus 3 is greater than 0, okay, because it can't be negative, then I'm going to subtract 3, so I'm going to have x is greater than negative 3. So then where's my domain from? Domain would just basically run from negative 3 to positive infinity. Okay, that's essentially what you're doing whenever you're finding the domain. Okay, is really just setting whatever's inside that parenthesis or greater. It has to be greater than 0. Same way with the x minus 5. Now, what about if it was x squared plus 1 greater than 0? Anybody have an idea of what my domain is going to be here? Close. So x has got to be greater than plus or minus 1. So I have two asymptotes here, right? Okay. If I have two asymptotes in this case, if we look at it, what do you notice? Where's my function running to? From where to where? Okay, it's not just a straight from one to the other, right? It's on both sides. So like in this case, my domain, so it's going to run from negative infinity to negative 1, and then from 1 to positive infinity. There's this area, this restricted area right through here that it can't be equal to. Okay, it's got to be one or the other. So it's going to come in from the left. Whereas even if I just change up one value, if I change it to a positive, instead of an x squared, common log, it's just a base of 10. So if there's no number listed, like log base 2, log base 5, If there's no number listed, it's just log base 10. So it's 10 to that power. Same way if they turn it into a natural log. Okay, if you had me last year, you would see me write the natural log, like if it was the natural log of x, that I would write this as log base e of x. Okay, the natural log is really just log base e. You can change it into that if you need to, especially whenever you have to find like the x-intercept, stuff like that. But as far as restrictions and what your domain can and cannot be, it's still the same setup here. You're going to set that equal to 0, like what can x not be. Okay, and it has to be everything from that direction, okay, or in that positive direction.